Hello students, my name is Mrs. S.J.Vanga, working as an assistant professor, Department of Humanities and Sciences, Walchand Institute of Technology, Solapur. In this session, we are going to study about indeterminate forms. Learning outcomes. At the end of this session, students will be able to solve the problems of indeterminate forms. Here we are going to study about type second indeterminate form, that is infinity by infinity form. Problems under this type are solved by using L'Hospital rule. Considering the fact that limit x tends to a f of x upon g of x is equals to limit x tends to a f dash of x upon g dash of x. If limit x tends to a f of x is equals to f of a, which gives you infinity, and limit x tends to a g of x is equal to g of a will be infinity, which forms infinity by infinity form. Therefore, we can apply the L'Hospital rule. As we know, the L'Hospital rule, it states that the limit of the function of the type f of x upon g of x is always equal to the limit of their differentials. Now students, note down the first problem. Prove that limit x tends to pi by 2 log of x minus pi by 2 upon tan x is equal to 0. Let I is equal to the given problem. Limit x tends to pi by 2 log of x minus pi by 2 upon tan x. Now students, substitute the limit as x tends to pi by 2. What we will be getting? Log of pi by 2 minus pi by 2. You are getting this as log 0. And we know that log 0 is always infinity. Denominator, tan pi by 2. Tan pi by 2 is again infinity. Hence, you are getting infinity by infinity form, which is an indeterminate form. And we know that to evaluate the limits of indeterminate forms, we apply the L'Hospital rule. Applying L'Hospital rule, that is differentiating the numerator and denominator. Yes, we will see what we get. Here, limit x tends to pi by 2, derivative of the numerator, that is log of x minus pi by 2 is 1 upon x minus pi by 2. And students, derivative of tan x is, yes, sec square x. Now, rearranging the terms, you are getting as limit x tends to pi by 2 cos square x upon x minus pi by 2. Yes students, now substitute the limit in this. You will be getting as cos of pi by 2, and we know that cos pi by 2 is always 0. Now in the denominator, yes, pi by 2 minus pi by 2, again you are getting this as 0. Means after substituting the limit into this function, you are getting 0 by 0 form, that is indeterminate form. Yes, to evaluate the limit of indeterminate form, we are going to use L'Hospital rule. So, by applying L'Hospital rule, limit x tends to pi by 2. Now, the derivative of the numerator is 2 into cos x, and the derivative of cos x will be minus sin x upon derivative of the denominator. X derivative is 1. Yes, now applying the limit 2 into cos pi by 2 into minus sin pi by 2. Yes, we know that cos pi by 2 gives you always 0 into minus sin pi by 2 is 1, and the 0 into 1 divided by 1 is 0. Hence, proof. I hope you have understood. Yes, students, take down the second problem. Here, prove that limit x tends to infinity x raised to n upon e raised to kx is equal to 0. Now, taking LHS and letting this as I, I'll get I is equals to limit x tends to infinity x raised to n upon e raised to kx. Yes, now substitute the limit as x tends to infinity. Yes, what you are getting? Infinity to the power infinity is again infinity. E to the power k into infinity, that is e raised to infinity, is again infinity. Means you are getting infinity by infinity form, which is an indeterminate form. So, to evaluate the limit, you have to apply the L'Hospital rule. Now, applying the L'Hospital rule to this function, you will be getting limit x tends to infinity. Now, derivative of the numerator, that is x raised to n, is n into x raised to n minus 1. Derivative of the denominator is k into e raised to kx. Now, substitute the limit as x tends to infinity. Yes, what you will get? Here, n into infinity to the power n minus 1, which gives you infinity. Again, in the denominator, k into e raised to infinity. Again, you will be getting this as infinity. Means, after applying L'Hospital rule also, again you are getting infinity by infinity form, which is an indeterminate form. So, the rule says that after applying the limit, if you are getting indeterminate form, you can apply L'Hospital rule n times till you get a finite limit. Therefore, again applying L'Hospital rule to this function means again differentiating. So, you are getting limit x tends to infinity n into derivative of this x raised to n minus 1 is n minus 1 into x raised to n minus 2. Derivative of k into e raised to x is k square into e raised to kx. Now, after evaluating this, if you substitute the limit as x tends to infinity, you will be getting this as again infinity by infinity form. So, if you apply this rule n times, you will be getting limit n tends to infinity n into n minus 1 into n minus 2 into dot 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 2 into 1 upon k raised to n e raised to kx. So, limit n tends to infinity. Simplify this. You know that this is the definition of a n factorial. That is n into n minus 1 into n minus 2 into so on 2 into 1 gives you n factorial. And the denominator k raised to n into e raised to kx. Now substitute the limit as x tends to infinity. So you are getting n factorial upon k raised to n into e raised to infinity. And you know that limit x tends to infinity e raised to kx gives you infinity. And n factorial upon infinity is 0. Now, third example, take down. Here you have to prove that limit x tends to 0 log to the base x sin x is always equals to 1. Now, taking your LHS as I, so you are getting this as let I is equals to limit x tends to 0 log to the base x sin x. Now students, here I am going to apply change of a base property. You can write this as limit x tends to 0 log of sin x upon log x. Now substitute the limit as x tends to 0. Again you are getting log of sin 0. You know that sin 0 is 0. Therefore, log 0 will be infinity. And log 0, infinity. You are getting this as infinity by infinity form. Means indeterminate form. Therefore, you have to apply the L'Hospital rule. Now, applying the L'Hospital rule, limit x tends to 0. Now, the derivative of the numerator log sin x is 1 upon sin x into derivative of sin x is cos x upon log x derivative is 1 by x. Now, students, rearrange the terms. You will be getting as limit x tends to 0 x upon sin x into limit x tends to 0 into cos x. Now, by using the standard results, you know that limit x tends to 0 x upon sin x is always 1 and limit x tends to 0 cos x is always 1. Therefore, 1 into 1, you are getting it as a 1. Hence the proof. I hope you have understood. References: Engineering Mathematics by Ravish R. Singh and Mukul Bhatt. Thank you.